Did you hear that? We better get started. I got to get out of here. All right, lesson number 5, properties and operations. So what we've done here is when something always happens, we give it a name. So we see this in science, the law of gravity, all right? We've got different items here. So we have some things in math that always end up happening, and it allows us to kind of go out of the order of operations and yet still be legal mathematically. So let's see some of these. So commutative is the first one. And commutative simply means like we're going one direction and then we're going the other direction. So people say like, oh, I have a 20-minute commute to work, which means it takes them 20 minutes to get to work and then 20 minutes to get back home. So it's the same thing going both directions. So in example number 1 here, 4 plus 7 is the same as 7 plus 4. 5 times 8 is the same as 8 times 5. You see what we're doing here? We're just flipping the order around. It doesn't change it. In addition, hey, you're still going to get 11 no matter what you add. Question 2, when you multiply, you're still going to get 40 no matter what you do. Look at question number 3. They're saying 12 plus m is the same as m plus 12. Yes, flip the order around. It does not matter when you are adding or multiplying. That is your commutative property. So, next guy that we got, all right, is your associative property. Associative, who you associate with. In other words, being grouped together. And what that means is hey, if it's all an addition problem, you can switch the order around and it doesn't make a difference. You see, in question number 1, we should be doing the 3 plus 7 first. Okay, if we do that, we get our 10, add on our 9. Hey, we're going to get 19. All right, well, if we move the parentheses, so that is a 9 that's still there, I'm going to do 9 plus 3 first and get 12. 12 plus 7, it's still 19. So mix the order up. It's all addition. Who cares? It's like going to the grocery store. You put your items on the conveyor belt. It does not matter the order you put them in. It's not like you go, oh, if I put the ice cream first and then the milk and then the hamburger buns, oh, I'm going to be saving money. No, it all adds up to the exact same. The same thing with multiplication, all right? 8 times 5 is 40. 40 times the 10 is going to give you your 400. Well, if we switch the order around, if we switch the parentheses around, 8 times 5 times 10, okay, 5 times 10 is 50. Well, 8 times 50, guess what? Still 400. So associative, leave the order the same, but if you move the grouping symbols, again, not going to change anything. If you notice here, we're not talking subtraction. We're not talking division. Only addition and multiplication. We got another one called the Additive Inverse property. And this is talking about that when you add them together, you're always going to get 0. Okay? So, in other words, the opposites. 8 and negative 8 are zeros. Which means are opposites. If you add them together, you're always going to get a 0. I got ahead of myself there. All right? Question 2, negative 7 and 7. They are opposites. Same number as in a 7, but one's positive, one's negative. So they're not really the same number at all. All right? We're going to get a 0. So, again, if we're going to combine and get a 0, it's going to be the opposites. The opposite of negative 23 is 23. Again, we're going to combine them together. So the opposite of 37 is a negative 37. So again, additive inverse, add them together, you're always going to get 0. Multiplicative inverse. Okay, so here, when we multiply two people together, you're always going to get 1. So multiplicative inverse is also known as, sorry, I want to make sure I get this right. Okay. Multiplicative inverse also uses something we call the reciprocal. So the reciprocal of 9 is 1 over 9. But when you multiply them together, you're going to get 1. 1/6 times 6, again, if I flip that 6 around, if I flip that 1/6 around, I'm going to get 6. 6 over 1 is 6 whole. So yeah. Here in question 3, I would change it to a fraction. Remember, we could do that, or I would accept this. 4/10, that's how we say it. That's just simplified down there. So yeah, you could put down a 10/4, because again, if we multiply them, we're going to get 1. You could, in this case, then put down a 5/2, because again, when you multiply those, you're going to get 1. Again, multiply them together, you get 1 always for the answer. All right. Distributive property. This is another kind of big one that we want to see here. The idea behind this is you can go out of your order for order of operations. So in problem 1 there, we're kind of taught, hey, go inside the parentheses. 2 plus 4 is 8. And then multiply the 9 times the 8 to get to 72. Okay, that's fine. But the other thing that we'll notice here is that a number up against parentheses means to multiply. And if you do 9 times 2 and 9 times 4 and add them together, you're going to get the same answer. Now, we'll show you the mystery here. So 18 plus 36. All right, that ends up giving us 54. Well, if we do 2 plus 4 and we get 6, 9 times 6 also gives us 54. So it's the same thing. We don't use this with order of operations, though. What we use it for is what you're about to see here in question 2 is when we start solving all of our equations, which is real soon, all right, the letters show up. I can't do 5 plus x. So by the power of distributive property, we can do more. So 7 times 5, 35. 7 times x, hey, that is 7x. So again, it allows us to go further, and we will be going further with this information. So, all right, let's summarize here, people. Commutative property, all right, we can flip the order around. So 4 plus 3 is the same as 3 plus 4. And again, I can just change it to a multiplication problem, same thing. Associative, all right, the parentheses move. So 1 plus, and then 2 plus 3 is the same as 1 plus 2 plus 3. Again, order hasn't changed, but the parentheses have. Additive inverse. Take someone, add on its opposite, you're always going to get 0. Multiplicative inverse. Oh, sprinkle some magic here, people. Multiply a whole number. Oh, we did that one up there. I don't want to do that again. Let's get you something new. I can come up with something better than that. All right. Multiply times its reciprocal, also known as its inverse. Synonyms, people. Look it up if you don't know it. All right. You're always going to get a 1. Distributive property. Again, this is where we end up seeing it, is with your letters. And again, this is why we got to get away from that extra multiplication. A number up against parentheses means to multiply, so we're going to multiply to everyone who's inside there. Now, there is someone else that we want to get to know that we're going to squeeze in there. All right. We've got the additive identity. And what that means is if you, and this is going to be earth-shattering, if you take something and you add 0 onto it, you get the same thing right back. Yeah. Again, if it always works, we give it a name that's there. We've got one more to put in there, and I'm kind of out of room a little bit, so I got to squeeze it in here a little bit there. Not only do we have the additive identity, but we also have the multiplicative identity. So I like saying that word, by the way. Multiplicative identity. All right? Well, the additive identity means if you add 0, you get the same answer. So the multiplicative identity, what do you multiply to get the exact same thing? Well, you multiply by a 1. So that's what we're looking at here. So, all right, people. Nice little kind of sheet to keep you organized. Got a little messy at the end there. My apologies for that. But the properties are something that will be hanging out with you for a while. So as much as it might seem like a bad thing, all right, they show up. They're going to help us solve our equations. They're going to provide? No, that's not the word I want to use. They will prove. They will prove to be, thank you, useful. All right, people, we're done here. Let's get out of here. I'll see you later.